Hi there. So on Friday, we derived all of these identities. Remember, the ones that are highlighted in orange are the ones that you need to memorize, and I will give you the half-angle identities. So we left off on the actual examples. We derived all of the identities, and we left off on the examples. This first example should look familiar to some problems that we worked through last semester, where you were maybe having to find the exact value of cosine of theta given some information. But now you need to find the exact value of cosine of alpha minus beta, where we know that cosine of alpha minus beta is equal to cosine alpha cosine beta plus sine alpha times sine beta. So we're using the identities now. And we're given that cosine of alpha is 1/3, so we'll be able to fill in cosine of alpha. And we know that cosine of beta is -1/4, so we can fill that in. But we still need sine of alpha and sine of beta. So let's start by finding sine of alpha. Now we're going to use cosine of alpha equal to 1/3 to help us determine what sine of alpha is, and also the fact that alpha terminates in quadrant 4. And remember, for these problems, I like to draw the picture to help me make sure I don't make a sign error in whatever unknown value I'm solving for. So let's say that this is the angle alpha, and remember that cosine is the ratio x over r. So a point that the terminating side of angle alpha could pass through could be, how about 1 for x? We don't know what y is. And then r, the distance from the point to the origin, could be 3. And we know that r is always positive, but x or y could be positive or negative depending on the quadrant we're in. So using Pythagorean theorem, the fact that x squared plus y squared equals to r squared, we'll have 1 squared plus y squared equals to 3 squared. So y will end up being equal to the negative square root of 8, which is -2 root 2. So sine of alpha is, remember, y over r. So sine of alpha is -2 root 2 over 3. And we still need to figure out what sine of beta is. Okay, so to help us figure out what sine of beta is, we are given that cosine of beta is -1/4, and that beta terminates in quadrant 2. So drawing my picture, let's say this is the angle beta, and again, x over r is cosine, so x is -1, we don't know y, and we know that r is 4. So Pythagorean theorem, -1 squared plus y squared equals to 4 squared. So y will be equal to the square root of 15. So sine of beta is equal to root 15 over 4. Okay, so we're almost done. Now we have sine of alpha, sine of beta. So to put that all together, to find cosine of alpha minus beta, fill in cosine alpha is 1/3. cosine beta is negative 1/4 plus sine of alpha, which is negative 2 root 2 over 3, and sine of beta, which is root 15 over 4. So then when we simplify and combine like terms, so we'll have negative 1/12 minus 2 root 30 over 12. So I'm going to pull the negative out front, and we'll have 1 plus 2 root 30 over 12. So that is the exact value of cosine of alpha minus beta. We don't know what alpha or beta are, but from our given information, we were able to find the exact value for cosine of alpha minus beta. Okay, this next problem is same sort of strategy. It's just using sine of alpha plus beta, which you guys know is sine of alpha cosine beta plus cosine alpha, oops, not A, alpha sine beta. And same sort of strategy, so I'm going to skip over this one, and if you need me to do it later, let me know. So I'm going to move on to this one, where we are given that cosecant of the angle x is equal to negative root 13, and cosine of x is greater than 0, so we need to find sine of 2x. And sine of 2x is equal to 2 times sine times cosine. So we can figure out what sine is because cosecant is the reciprocal, remember? So that means that sine would be equal to negative 1 over root 13. Now, we want to figure out what cosine is. And all we know is that cosine is positive. Well, cosine's positive in 2 quadrants. Cosine's positive in quadrant, all students, so quadrant 1 take calculus, and quadrant 4. Well, sine is negative in quadrant 3, in quadrant 4. Okay, so that means that the angle x is going to be terminating in quadrant 4. Okay, that's where both of those pieces of information agree. So I'm going to draw a picture of angle x terminating in quadrant 4. I need to be careful about my notation because this is angle x. And sine is y over r. So I don't know what, I'm not going to call that x. I'm going to call that a. Okay, I'm going to call the x coordinate a since we already have the angle named x. But we know that y will be negative 1, and then r is equal to root 13. So a squared plus negative 1 squared equals 2 root 13 squared. So a is equal to root 12. Positive root 12, which is 2 root 6. So cosine of x is going to be 2 root 6 over root 13. I'm going to leave it that way for a second because things might clean up once we've actually substituted into the identity. So sine of 2x is equal to 2 times sine times cosine. And yep, they do. So that is negative 4 root 6 over 13. So that is what sine of 2x is equal to. All right, this next one, it's the same sort of strategy that we're using to answer this question. And these types of questions can also be seen on the SAT too. But this next question is cosine of x over 2, which is half angle identity for cosine. So plus or minus the square root of, I'm having a brain fart, is it 1 minus or 1 plus? Going up to the half angle identities, which I'm giving you anyways. So 1 plus, I can't remember if it was 1 minus cosine or 1 plus cosine. So 1 plus cosine over 2. Okay, the issue here is, this is that cosine of x over 2 is equal to potentially two different values, plus or minus. And we know that cosine of x over 2 can actually, for the angle x over 2, can only be equal to one value. And it's our job to determine whether or not it will be a positive ratio or a negative ratio. I'm going to give myself a little extra room for this one. Okay, so the way that we figure out whether or not we're using plus or minus is look at this inequality we're given. We're given that x lies between pi and 3 pi over 2. Well, that's saying that x terminates if we treat x like an angle, the angle x terminates somewhere between pi and 3 pi over 2, which is quadrant 3. Well, if I take that same inequality and divide each part by 2, oops. I end up with x over 2 is greater than pi over 2 and less than 3 pi over 4, which that means the angle, this angle, terminates in quadrant 2. Well, cosine, all students, cosine is actually negative in quadrant 2. So we can actually ignore the plus here because we know that our ratio, cosine of x over 2, is going to be equal to a negative value. Okay, so we are in quadrant 3 for the angle x because notice that the information we're given here, tangent of x, is equal to 12/5. So we're given information about the angle x, which terminates quadrant 3. So the picture I'm going to draw is going to be of quadrant 3.